playing in the right presentation format?
Yes, it is.
Excellent. Right. Okay. So thank you for the opportunity to present on the East Coast Digital Programme and what it means. It's a programme that I've been involved in since 2020. So yeah, hopefully you'll find it interesting. So in terms of what I'm going to talk about today, I want to talk about, why the East Coast Digital Programme. What does it mean in terms of, the benefits to the country? A little bit about the business case, as we're a benefits-led programme. Our roadmap to transforming the railway, taking benefit from digital technology. A little bit about principles of operation of ETCS, and then a little bit more detail in terms of what do we mean by the East Coast Mainline South. What does it entail? And then at the end, time for hopefully some time for some questions. Okay, so why ECDP? So first of all, we are one program, around about £2 billion. So I think we're one of the biggest rail programs outside of HS2. I think it's HS2, and then I think it's kind of East Coast Digital Programme. We are following an MSP approach, which means that we are divided into effectively 5 tranches, and within the kind of main 2 of those main tranches, we're realising the transformation within sort of 12 incremental steps. But I'll come on to that a bit later on. We have got, I've just realised you're showing the wrong one. So we achieved the full business case in 2021. We've got around about 5 years to go. But of course, with all these programmes, the timescales can be quite challenging. It is because of the area we're working in. It is a wide-ranging program in terms of the number of stakeholders that we impact. So we impact around 27 duty holders. So they're mainly the railway undertakings that are impacted by what we're doing and need to be fully involved in the program, and that will become evident a bit later on. And yeah, we've got a lot of vehicles, signals, drivers, and staff to either change, modify, or train. So hopefully that gives you a little bit of an overview in terms of the scale of the program. Oh, and then probably the only other thing I probably should have mentioned at this point as well, it's about 100 miles. So it's about 100 miles from King's Cross to the other side of Stoke Tunnels, so around about Grantham. So it's about 100 miles of railway of the East Coast Mainline South. So as I said, we are a benefits-led program. So we are trying to maximize the benefits that we get from digital technology, and the 2 sort of key drivers for this is one, the East Coast Mainline is pretty much up to capacity, and we need to provide more capacity for passengers, because it's quite a well-used line, not only for commuters but also for people going on holiday, recreation travel. So it's not just commuters, but of course there is a large element of commuters as well, but also it's quite a busy freight corridor, so there is a need to provide additional capacity for passengers, but also for so we can run either more freight trains, heavier freight trains, longer freight trains, or faster freight trains, as the freight community like to talk about. But also the cost of signalling is increasing, so we need to find ways of making signalling renewals more sustainable, and also better from a kind of carbon footprint perspective as well. So in terms of kind of why East Coast now, about 2/3 of the signalling assets along the network from the East Coast Mainline South are life expired and need renewing. The cost of signalling and replacing like for like is increasing, and also the number of suppliers is decreasing as well. So it's becoming less and less sustainable. The future is seen as digital signalling. It's been around for for many decades now, actually. So it's not necessarily a new technology, but it's still, quite a new technology to the railway. But its principles are well understood, and there's, a lot of experience worldwide. Some of the benefits of digital signaling is that it does provide much greater flexibility in the terms of, what benefits we can unlock from digital signaling. And signaling, as you're probably well aware, tends to be a constraint on the capacity and the capability of the railway, in that it's a safety system. So its main function is to prevent trains from colliding or derailing, and of course that puts a constraint. So in terms of moving to the next generation of train control systems, the East Coast Mainline South represents a kind of once in a lifetime opportunity. If we don't do it now, then it becomes very hard to do it for future generations. So strategically, this is a very important program for the country as a whole, because it basically will set out the blueprint and the template for future signaling utilizing digital systems. Okay, so in terms of the technology, so we are using something called implementing something called the European Train Control System, ETCS, and I'm sure a lot of you have probably heard of ETCS, and probably know what it means. But effectively, ETCS has been designed as an interoperable automatic train protection system, and it was first started in the 1990s, and this was primarily to try and reduce some of the barriers to trains passing through country borders, where each country had their own train protection systems, which would mean that trains would either need to carry multiple train protection systems so they could operate over those systems and switch between the two, or you'd have to actually change the loco, which has happened at some country borders. So the whole idea of having an interoperable system was first conceived kind of at the probably late 80s, but certainly early 90s was when the work really started to define what we mean by an interoperable system. The benefits from that as well is that it does reduce cost, because we've got far less monopolistic situations. We've got a larger product base, so it drives kind of those costs down. And as we can see, although it was started in the 90s, and the first specs were issued from 2006 onwards, the system is still being continually refined to meet the needs of the railway operators, because all railway operators have their own kind of unique needs. We, as a country and as an island, we have our own we have our own needs compared to Germany or Denmark. But Germany and Denmark also have their own peculiarities that they like to retain. One of ours happens to be miles per hour. So as I said, ETCS, it provides a continuous automatic train protection using in-cab signaling. So line side and route information is sent to the train, and it's displayed to the driver, and the onboard systems, the onboard computer systems on the train enforce that information. So they'll make sure the train doesn't overspeed, make sure it doesn't exceed what would have been before a red signal is now a signal within the cab. And it does this on a continuous basis by continuously monitoring the speed of the train and the position of the location of the train, and making sure that it's still within its safety envelope as defined by the signal system. Sorry about the dog barking. So in terms of realising ETCS on the East Coast Mainline South, as I said, we're realising it through 5 tranches. So the first tranche was the Northern City line, which is a branch line from Finsbury Park to Moorgate, and that was done very much as a pathfinder, so we could learn more about how we were going to deploy ETCS, and I'll talk about that in a bit more detail later on. We then got what we call our first migration area, the East Coast Mainline South Mainline, which is well into Hitchin. And we're using this as part of the driver training, so enables the practical handling element of the driver training on ETCS to occur before the driver is fully certified to operate in ETCS. We have a third tranche, which is about looking at improving our traffic management systems. So looking at systems that improve the way in which we maintain timetable, punctuality, provide information to the drivers, things like that. That's tranche 3. Tranche 4 then is the progressive rollout. So if you like, we're pretty much into the production line. When we get to tranche 4, where we're rolling out ETCS as a no signals railway, so removing all our colour light signals. And replacing it with cab signalling over the 100-mile stretch. And then tranche 5 is really optimization, that once we've learned how ETCS really behaves, some of the benefits we can get from it, it allows us further optimization in terms of what capacity we can get out of this system and things like that. Okay, so I did mention that we do have a lot of stakeholders because of the way in which the industry is structured. We have an awful lot of stakeholders and bodies that we need to work with in order to be able to deliver this change to the railway. Some of those are own the vehicle, some of those operate the vehicle, some of those own infrastructure, some of these are unions, as you can see on there, that have a say because of the safety impacts and the impacts to their members. We also have safety authorization and regulatory bodies. So the way in which we are trying to do this in an industry that is not particularly well integrated is to set up a cross-industry partnership, and East Coast ECDP is very unique in this perspective, in that traditionally the way in which changes are managed in the railway, Network Rail tend to define the change. So this is we're bringing in new track or whatever, and it's down to the train operating companies or the Roscoes to make sure that their trains are okay with that track. And that is usually managed through network change. And of course, we still have network change, but the way we've tried to do this is to set up a partnership where the partners are involved in the specification and the design of the system, so that they have more say in the game, and we're clear on what they need and the impacts to their business, so that they're not disadvantaged in any way. So it is quite a unique partnership that I'm pleased to say is actually working, although it's gone through a number of pains to get to that point. Okay, so a little bit about principles of operation, because I'm sure you're dying to know how signalling really works. So in a conventional signalling system, we have a colour light signal. So if we have a red light, there's an overlap associated with that red light, that should the driver pass that red light, there's enough time for the driver at full speed to stop before whatever the obstacle is that red light is protecting. So it could be the back end of another train, it could be an unlocked set of points. And then in ETCS, the principles of operation are very similar. We replace the red light with a marker board, and you may have seen some of these marker boards if you've ever travelled on some ETCS equipped railways. Certainly if you go on Thameslink, you could see some of these, and Cambrian. But yeah, so essentially we replace the red light with the marker board, and the onboard computer continuously monitors the performance of the train, so the braking performance of the train. So it knows how that particular train consist will behave, will brake, and it receives movement authority and speed information from the wayside, which it uses then to calculate its braking profile. So based on how far it can safely travel to the end of authority, before it gets into the before it exceeds that, the train will construct a braking curve back from that point, and will then continuously monitor the train performance, and whether it's still within that braking curve, and it provides that information to the driver so that the driver can drive the train to that movement authority. So the driver will see the end of the marker board and will know that the driver that effectively that's a red light, and the driver will be controlling the speed of the train to stop before that marker board, and the onboard computer will be monitoring the driver's performance in effect. And there you see that that's the braking curve that the onboard computer would have constructed for that particular type of train and consist. So in terms of our key building blocks for ETCS, we have the kind of conventional signaling elements of it. So the interlocking quite often will be changed so that it's a system that is compatible with ETCS. So that there will normally be computer-based interlockings that we have. But essentially the key components are, we have a wayside elements which comprise of a radio block center, RBC, which is effectively a computer that it kind of knows the state of the railway, so it knows where the location of trains are, which it receives from the interlocking, but through block occupancy. And in terms of block occupancy, we tend to use axle counters rather than track circuits. So from a track perspective, the good news is that we get rid of IRJs, and the bad news is we put axle counters in instead, which obviously gives you an issue when it comes to grinding and things like that. But yeah, so we monitor the train positions through track-based train detection systems, which, as I said, is normally an axle counter because it provides greater reliability than track circuits. And that information is passed to the radio block center along with the kind of state, in terms of basically route information, in terms of whether the track is free. It gets sent to the radio block center, which also then has all the information about the train types in terms of what the static speed profiles are and things like that of the track, which it then sends to the onboard computer via the GSMR network. And then on the train itself, we have the European Vital Computer, the EVC, which is kind of the brains of the system, because it is calculating the braking profile for that type of train based on the static speed profile provided by the RBC and the movement authority. And that will use things like Doppler radars and tachos to determine its location and its speed. And we have balises in the track, which obviously, when it comes to things like maintenance, we need to make sure those balises don't get moved, because they are there as absolute position reference systems for the train, so the EVC knows exactly where those are. So those are our kind of key building blocks. In terms of capacity improvement, how do we get capacity improvements out of a digital rail system? So in conventional signaling, we always maintain we maintain kind of two signal or a signal section, but two signals in between a train, as is shown here. So you've got that free section in between. In ETCS, we still follow the principles of fixed block detection, where we have at least one free block between trains. But because we are controlling the braking of the train and we know where the train is going to stop, we can allow the trains to follow each other at closer intervals than for conventional signaling. So in a conventional signaling, where you have a signaling selection as shown above, where you'd not expect to see another train in that signal selection, you expect to see it clear. With digital rail signaling, we can actually have a train in between those blocks. So that allows the system to improve capacity, especially in terms of improving the punctuality of the railway. Because under kind of perturbed conditions, if we can close the trains up, if we can get the trains closer, we can recover the perturbation quicker, which then adds more resilience to the timetable, which you can take as either additional capacity, so run more trains, or you can just take it as being able to run the timetable far more reliable, depending on kind of what sort of service the operator wants to provide. So I talked a bit about the in-cab signaling. So one of the key interfaces is the driver machine interface, because this provides all the information to the driver that the driver would either know through things like route knowledge, or would obtain from the line side signals. So so in this case, as you can see, we provide, ETCS provides a wealth of information to the driver. An example shown here, we're showing that the maximum permitted speed for this section of the line is 145 miles an hour. Sorry, kilometers an hour. This one's shown in actually, which actually isn't a UK standard, because we're using miles per hour. And the current speed is 133. The driver needs, or there's a speed restriction or something, which is around about I think it's about 80 meters. Sorry, 800 meters. Sorry, 800 meters to get that planning area on the right hand side. As the driver needs to obtain a reduced speed to 80 kilometers an hour in about 800 meters. So this is all the sort of types of information that's provided to the driver to help the driver drive the train. And this is a standard interface, so that it looks and feels exactly the same for all drivers. Okay, so a little bit more about East Coast Mainline South. As I said, we are migrating in 12 stages. So the first few of those stages was to upgrade the Northern City line, and then we will be progressively rolling out from Northern City line. So we're currently in phase 6 on there. So phase 6, which is in the middle row, the bottom left hand side. So that's Wellington Hitchin. So we've just renewed the signalling in Wellington Hitchin, and are now testing ETCS, ready to start driver training in kind of summer next year. So going through the testing and the proving of that system, and then whilst we're undertaking driver training, we'll be progressing with developing ETCS for the rest of the East Coast Mainline South, which is phases 7 to 12, and implementing that in a no signals format, apart from Peterborough, where, because not all trains that will be traversing over Peterborough will be fitted with ETCS, we have to retain some overlay in that area. We'll also be coming back and replacing the migration area, the Wellington Hitchin, which is currently an overlay with signals to allow driver training. We'll be replacing that with a no signals, so we're basically taking the signals away. So that's our migration strategy. A little bit about tranche 1. So yeah, this is the Northern City line. So this is the Northern City line. So this was from Finsbury Park to Moorgate. We've used it very much as a pathfinder to learn, to really sort of learn about some of the challenges around implementing ETCS. At that point, the interlock, all the signalling needed renewing anyway. So I think it was last done in the 70s. It was effectively a follow-on from the scheme that's currently in operation on Thameslink. So it uses the same RBC. So it's not quite the same version of RBC that we will be using on Wellington Hitchin. It's an earlier version to an earlier specification, but some of the benefits that has brought in that it's now improved the reliability in that area, on that line. But we have learned a lot of lessons in terms of the authorization of ETCS, testing, things like that. So it's delivered a lot of benefits in terms of kind of the lessons learned. So it's been a good pathfinder, and we've built those into Wellington Hitchin. I can't admit that it went very smoothly. There was certainly a lot of pain in getting it into operation, but those were valuable lessons. In terms of our first overlay, so this is our first migration area. Went into Hitchin, and it was purposely chosen because it's a feature-rich railway. So we have many features that enable us to really sort of enhance the driver training. So we've got the 2-track section around Welland North and Digswell, which also puts a bit of a constraint on the railway. We've got multiple operators going over there, so nearly all the operators on East Coast Mainline South will operate over that stretch of the railway. We've got passengers, the MU sidings. We've also got freight sidings. We've got a number of junctions. Some fairly sort of complex track layout. So we've got a lot of good features that enable us to really sort of test ETCS and also provide provide a good backdrop for training. One thing we don't have on there, which I think is good, is level crossings. So we haven't got to worry about level crossings, but they will come very soon in tranche 4. So that's our first overlay area. So as I said, we completed the signalling of that section in March this year, and we're now in testing with a view to start driver training with at least one operator, which will probably be Thameslink GTR in around about summer next year. In terms of train fitment, so we have a lot of different classes to fit, and so a number of different passenger stock, quite a lot of freight, mainly the class 66, 67s, but quite a lot of freight, a lot of different classes. Also heritage and charter, so we are fitting steam trains. Interestingly enough, the steam train that's shown there, which is the Tornado, is actually newer than a lot of the freight we're fitting, certainly newer than the Class 66. And we're fitting some on-track machines, not yellow plant, but on-track machines. So things like tampers, stone blowers, things like that, rail grinders. Rail grinders is quite an interesting one to fit, actually, because part of the operation for the rail grinder is that if they need to go back sometimes if they've set fire to the embankment. And as a principal operation, ETCS doesn't normally allow that kind of operation, so that's something that we need to build into the system to make sure that we can do things like that. So what have we achieved so far? So we've undertaken a lot of signalling renewals. We've upgraded the Class 717s to the latest baseline. We've got NCL into operation. We've started system proving, but we've still got a lot to do. Still got an awful lot to do in terms of bringing in some of the new systems. We've got to complete driver training by 2027, complete all our train fitment by 2027, achieve our first signals away 2027, and then complete at least tranche 4 around about 2029. So we've achieved a lot and learned a lot, but we've still got a long way to go. Some of our key challenges, as I mentioned, we have an awful lot of trains to fit, a lot of retrofit, which is really difficult, lots of challenges. I'll talk about that in a couple of slides. We're working with a lot of suppliers. We're working with all the major ETCS suppliers, are involved in one way or another on East Coast Mainline South, which is good in some respects, but that obviously then each one their systems are slightly different. They each present an integration risk, and also we've got to interface with different supplier organisations. We've got quite and also we've got a lot of operators as well. We've got new technology we're bringing in, so online key management. So online key management is the mechanism by which we distribute the authorization keys to the onboard systems, so that when the onboard system dials up the RBC, it knows it's dialing up the right RBC and it's authorized to do so, so that the RBC can be clear about which onboard it's communicating with, and it's allowed to do that. We have we're implementing the latest interoperability specifications, but that also includes specific UK functionality, which currently is unproven. We have to make sure that whatever we do doesn't mess up the operation with Thameslink, which is currently operating on ETCS. So we've got to make sure we remain compatible with that. Safety authorization has caused a real challenge for us, but I think we've learned a lot, and we've put things in place that should improve this. And we're also, because what we're doing, because ultimately ETCS is a national system, we need to make sure that whatever we do provides a consistent view to the driver and a consistent experience to the driver. So we are implementing ETCS in accordance with the digital rail requirements. So Network Rail set up a program, if you like, which over about 10 years to develop a reference design of how ETCS should be implemented on the UK rail network. And obviously, as a first program to implement that, we're finding challenges and issues in that. So in terms of train fitment, this is a challenge. It's kind of a tale of two halves in many ways. With a lot of the passenger rolling stock is new. It comes already with ETCS fitted and in use in some ways. So currently, a lot of like the Zoomers we use elements of ETCS for things like correct side door enable, for power control and things like that. For the Class 700s operating on Thameslink, they already have ETCS in operation and are using it, as do the Class 717s now on NCL. So in some cases, the upgrade is really more just uploading new software. So it's almost like kind of updating your software on your PC or your phone and things like that. Not always the case, because in some cases we do need to implement new hardware, but a lot of it is it's well understood. You don't have to do much modification to the train. The other half, where we have a lot of older existing rolling stock that was never designed with ETCS in mind, requires an awful lot of work, a lot of challenges. Finding space, fitting ETCS is intrusive in the train. It's got to interface with any train management systems. It's got to interface with the brakes. It's got to interface with the propulsion. It's got to. We've got to put the DMI somewhere where the driver can see it. So you've got to consider things like ergonomics and human factors. And also the equipment. There are quite tight constraints over where some of the equipment can be fitted in order to make sure it's interoperable. So you can read the balises in the right place, and it doesn't mistake the position of the front of the train or the rear of the train, which would be could be a problem from a safety perspective. So so it is a real challenge, and what we find is that not all the rolling stock is consistent. There's a lot of variation, and even from when it's surveyed to when we actually install, we've had all sorts of problems with taking roofs off, fitting the ETCS equipment, and then not being able to actually fit the roof back on. And we're even fitting it into steam trains. So as you can imagine, that looks like a beautiful piece of engineering, and all that pipe work and stuff like that. It's like a work of art, and you can imagine that kind of environment when you've got the boiler the fire going, the boiler going. It's a very smoky, steamy environment, and we're putting a DMI up there that the driver needs to interface with and press buttons and things like that. So but also try and maintain the look of the train as well, not spoil the train. But we have found solutions around that. So found solutions to fit even difficult trains that haven't been fitted before. So in terms of learning from experience, so what we've learned is you need kind of bees and nerds. So you need bees to go around, and because we're not the only ones doing this. There's a lot of countries in Europe and even worldwide are installing ETCS or have experience with ETCS. So you kind of need bees to go around and gather information and intelligence and stuff like that. And then you need nerds to fix problems when we encounter the problems. So you kind of need bees and nerds. But we're even finding that even though some of our European colleagues like Switzerland, Denmark, have installed ETCS and understand ETCS, they're also learning from us as well, because the scale which we're doing on is maybe wider than they have, or implementing new systems like GPRS and OKMS that they haven't yet done. Safety authorization, as I said, this was a big challenge for us on NCL, because the process wasn't very well understood. Because we've split the safety function across the infrastructure and the onboard, the main burden of proof is proving that the system is safely integrated, that safety function, that the onboard system is completely compatible with the infrastructure, and that if it's not completely compatible, that any incompatibilities are safe, and that's quite a burden of proof, because we've got different suppliers, different railway undertakings providing that information, and so it's a massive kind of integration problem, and that's one thing we found from NCL. Trying to make that argument was quite challenging, and the systems weren't set up really to enable that. So this is the revised safety authorization process. At the centre of the universe is something called the Systems of Systems Safety and Security Panel, which basically looks at all that evidence and says, based on this evidence, we're happy that the system is safely integrated. So, very quick summary. From my perspective, ECDP is an enabler. It's an enabler for the benefits of digital signalling. There are a lot of benefits to the end user and to the system owner in terms of kind of reduced cost, a more sustainable railway, better capable, or a more capable railway. It certainly is a building block to higher levels of automation. Provides a lot of information, so we can improve things like train management, traffic management. Have higher levels of automation in the railway, and leads to a more sustainable railway. So those are just a few of my own reflections of the benefits and of digital technology and ECDP as an enabler towards that. So that just leaves time for any questions.
Hi, Paul. Thanks for that. That was a very interesting talk. And it looks like we've got quite a few questions that have popped up. So what I'll do, I'll read them out, and then you can answer them. But also, if there's anyone on the call who wants to actually ask their question, just pop your hand up and we can go to you. And it's always good to hear a voice and see all our members, so don't be shy. But to kickstart off then, okay, so Tony sent a question asking, do we know how ETCS compares to coloured light signalling in terms of safety and incidence of indicators passed when not safe to do so?
Yes. It's a really interesting question. That ETCS provides a higher level of protection because it basically takes away the SPAD, and that's one of the things that the drivers really like about ETCS. As the driver says, it keeps their ticket clean, because no longer now are they responsible for a SPAD, because the ETCS will intervene. So it does provide a higher level of protection, but TPWS in itself does provide high levels of protection, as has been demonstrated. And so if you're just trying to make a case for ETCS on a safety benefit basis only, it doesn't really wash its face. So we have got figures for what the business benefit is, or what the benefit is from safety from a kind of numerical perspective, but it's not really that high. But it does reduce SPADs. It does provide a high level of performance. But ETCS in itself, you wouldn't do ETCS as a safety system alone.
Okay, thank you. So the second question, which is from Chris, where there will be permanent overlay between ETCS and standard signalling at Peterborough, how would the system or signaller know which signalling type to use? If a train is using ETCS, would the line side signal still clear to green, etc.?
Yes, it does. So if it's ETCS, then the signal the signal does change to green. The signaler knows which train is operating on ETCS. It's actually displayed on the signaler's workstation. So the signaler have a workstation which demonstrates which trains are in ETCS and which are not ETCS and are operating on overlay. And these principles are these principles are proved on Thameslink, where it operates in overlay, but also currently on NCL, and obviously we will prove that again on OMA. But it's the kind of principles of operation are quite well understood now. But yeah, I mean, effectively it's displayed on the signaler's workstation.
Okay. Okay. Next question from Clement. Apologies if I pronounced that wrong. Only driver training is mentioned in the migration strategy. Is there a plan for other skill capabilities, so operators, engineers, etc.?
That's a really great question, because yes, part of the business readiness element of the program is about training all the other operators, and in some cases those operators need to be trained, or operators and maintainers need to be trained prior to enabling driver training. In fact, driver training is probably one of the last pieces of training that we do. So the operator, the signaler, for example, needs to know how ETCS works, and we need to be able to demonstrate that the signaler is competent to operate ETCS in order to be able to start driver training. So part of that safety argument is that the driver is the signaler is trained. Similarly with maintenance, and where we change things like access arrangements and stuff like that. All this training needs to be done. We need to be able to demonstrate that the operator is competent before we get the authorization to place anything into use.
Yeah. Okay. Next question from Ranga. He said, "This looks like ETCS level 2. Is there any reason why we're not considering ETCS level 3?
Yeah, great question. When I first started on ETCS in 1998, I think it was, that's exactly what we were going to do, level 3. I mean, level 3 is that's the way to go. The main things that constrain level 3 is being able to prove train completeness. So the challenges around local hauled, where we don't necessarily where we don't necessarily have round train circuits that can demonstrate or prove that the train is still complete. Those are kind of some of the key blockers. But yeah, I mean, it will eventually come. I mean, that's why I say this is an enabler which allows us to move on to it's kind of one step at a time, if you like, and it's taken us 20 odd years to get to this point.
Yeah, good question. Okay, next one from Phil. So he's asking, is the braking distance calculation conservative? For example, does it assume the worst case braking performance to account for factors such as wear on the braking systems, wheel slide, tailwind, etc.?
So yes, so it takes into account things like gradient. So the RBC sends the gradient information along with the movement authority, so the EVC takes that into account. It does take into account a number of different factors that it doesn't necessarily, it is optimized, so it's not necessarily worst case, but certainly, I mean, certainly we take into account things like worst case positional errors and things like that. But the braking performance is normally calculated on certain loading conditions and also the coefficient of friction. And that's, that is a bit of a challenge really, because, as you're probably aware, steel wheels on steel rails. Yes, the braking performance is relies completely on the coefficient of friction, and when we have things like leaves on the tracks, slippery rail conditions, the braking performance isn't designed to cope with a slippery rail. If we have slippery, what we need to do is obviously the track conditioning, which obviously network rail does, but also put in other defensive measures like drive the train slower and brake it earlier for if we have poor rail conditions. So hopefully that answers the question. but it does take into account all sorts of things like in rotational masses, the weight of the train, things like that. And some of that's built in because, like the local hoard, for example, the consist of the train, the loading will be very different, and that needs to be programmed in as part of the consisting of the train, so it can be dynamic. But that that just then comes into, well, okay, it's this RA category for the train, so it gets this braking characteristic.
And then there was a follow-up question from Phil. He also said, are there more onerous maintenance requirements on ETCS compliant rolling stock, for example, to ensure the brakes are performing in line with their design specification?
So the answer to that question is no, because the railway undertaking should be doing that already, as part of their safety, their safety management system. So basically, the train needs to be compliant with standards. So as long as the train is compliant with standards, then ETCS doesn't require any more onerous maintenance, because the railway undertaking should be doing that already.
Okay. And obviously, everyone feel free to sort of dive in and ask your questions instead of me just sort of bombarding Paul with a big list here. But we've obviously had quite a few drops in the chat, so I'll carry on. Another one, this one's from Roger. So you're saying, in areas where conventional signalling remains, is it possible for a train to legally pass a red signal?
Only if it's got a movement authority. So if it hasn't got a movement authority, ETCS won't allow it to pass the red signal. Obviously, we've got to consider things like degraded modes. The signal might be red for because of signaling failure, in which case we do have mechanisms of getting around that. But that will normally require authorization from the signaler to pass that signal at red. Unless we lose complete communications. But the only time we'll allow the train to pass the signal at red will be by authorization of the signaler, and it will be in a degraded mode.
Okay, thank you. I missed Rob's question, so I'll just go back up a little bit. So Rob was asking, what challenges have you faced with fitting the ETCS kit, the steam locos? Are there other locos in the pipeline for fitment, or does it depend on the lessons learned from fitting Tornado with the kits?
Great, yeah, that's a great question. So yeah, a lot of lessons. One thing they tried to do, so I mean, obviously some of the challenges around fitting some of the heritage stuff is that you need to kind of maintain the look of the train, so because people like to look at a steam train, they don't want to see a big yellow box there if you can avoid it. So they have disguised some elements by making it look like a toolbox. So there's the kind of the aesthetics, if you like. There was a lot of ergonomic challenges, as I mentioned, and the way we got around that was by having sort of like putting in a duplicate unit in the tender. So so we're not just relying on the driver. So there's a kind of slave unit in the tender. We also have designed it so it's quite modular, so that it can be replicated onto other trains as far as possible to try and reduce the cost. But it was a pilot, and the cost is probably higher than forecast at the moment. So there are a few challenges around that, but there are certainly a lot of lessons, as I said, in terms of kind of where we place equipment, how we make it look, the ergonomics, that we've certainly taken into the other fitments.
And has that affected the way it's looked? Because obviously the main thing is keeping that characteristic, isn't it, of the old heritage locos?
Exactly. Yeah, I think in some case, I don't think it's ever so noticeable. I mean, they have to have some stuff like radios and stuff anyway. But where it was, where it could be disguised, we've disguised it. As I said, like made it look like a toolbox, which is look quite neat. Don't know what was in that. What was in that, but it did look. It kind of had this toolbox on the end of the, on a bit of the train.
That's good. Okay. Another question from Clements. He said, signaling renewals are bound to increase on the network, and with its ETCS technology, how is the industry geared up from the supplier point of view, especially with regards to testing and commissioning resourcing?
Yeah, great. Great question. So NovaRail recently let a framework contract called the Train Control Systems Framework, and in that, I think they've let it to, I think it's 4 suppliers. So they've got four suppliers. So they're trying to make sure they've got some diversity in their supply chain, and they don't end up in a kind of monopolistic situation. As part of that, all of the suppliers are required to demonstrate that they are capable of implementing ETCS. So they need to use the time from now until deployment to make sure they've got all the resources, they've trained all the resources. NovaRail have also provided a test facility. In fact, 2 test facilities. We've got the test facility at Old Dalby, and also the one at called ENIF, not ENIF, sorry, the NETL, sorry, National ERTMS test facility in Surrey, where suppliers can go and test their equipment and use that to demonstrate, to provide evidence, of compliance and things like that. So it's kind of been recognised in the way in which the frameworks have been set up, and the onus has been placed onto the supply chain to get their capability ready, or be ready to implement and deploy ETCS, in line with the investment program. So it's roughly around CP7, CP8, I think.
Okay. Before I wrap this up, do we have any more questions anybody would like to ask or pop the hand up? Or silence.
Well, it's a good set of questions, so thank you for those.
Good. Well, I'd like to say on behalf of the PWI, we're very grateful for that talk, Paul. It's been a fascinating insight into what's happening on the East Coast Main Line. And then I'd just like to put a note out there just for the next meetings coming up. So you should see some notifications soon regarding the Christmas event. So I'm currently looking at various venues, but I'm hoping to arrange some kind of social for the first week of December, possibly the 4th of Wednesday the 4th. So perhaps keep that one free, but please look out. Obviously the summer social was a really, really good success, so I'm hoping we can do something similar for the Christmas do as well. Again, thank you for everybody attending, and once again, thank you, Paul, for your time. I will leave it at that now, so goodbye, and everyone enjoy the rest of your day. Okay, thank you all.
Bye.
Bye-bye.